Data centers already account for over 3% of global electricity consumption, and the number is rising. In this episode of KubeFM, Dave Masselink, the founder of Compute Gardener, explores how Kubernetes is being used not just to scale workloads, but to scale more responsibly. He dives into practical strategies for reducing energy consumption across clusters, including CPU power capping, workload scheduling based on energy profiles, and leveraging Kubernetes node feature discovery, or NFD, to better match applications to hardware. Dave also unpacks the importance of platform observability, describing how his team builds telemetry pipelines with tools like Prometheus and Grafana to track sustainability metrics in real time. He walks us through what it means to manage infrastructure with a carbon-aware mindset and how Kubernetes native tools can help operators optimize performance while minimizing environmental impact. We're excited to partner with TestCube for today's episode. Testing applications in Kubernetes doesn't have to be complicated or slow. TestCube is your go-to platform for cloud-native continuous testing. With TestCube, you can effortlessly orchestrate, scale, and automate tests right within Kubernetes, catching issues early and deploying with confidence. Try it out today and see why engineering teams trust TestCube to keep their testing simple and scalable. Visit testcube.io to get started. Now, let's get into the episode. Dave, welcome to QFM. What are 3 emerging Kubernetes tools that you're keeping an eye on?
Well, thanks so much for having me, Bart. Looking forward to this opportunity to have the discussion with you. The 3 that I'd point to, I think, the first one is the Kepler project. That I think is an acronym for Kubernetes Efficient Power Level Exporter. So that's a Prometheus exporter that is for tracking power down to the container level. I think we'll talk a little bit more later on about why that's especially interesting and relevant to me. But they just had a big rewrite, ground up rewrite and a new release. So I'm trying to get caught up on that. Another project I'd point to, these aren't all emerging projects exactly, but some of them are new to me. And the next one is the Cloud Native PG. That's, Postgres, Cloud Native attempt for Postgres. Throughout my career as a software engineer, I've had dozens of times where I've had to deploy a Postgres database, and even a few times in Kubernetes with stateful sets, and definitely appreciate the patterns that Cloud Native PG is bringing to the game to simplify things a bit, especially in our complex Kubernetes stack. And then I guess the last one that I'd point to right now, probably not tracking this one quite as closely as those other 2, but there's the Kube Edge project. As its name suggests, it's about edge computing. The high level is that it gives a kind of cohesive view, even though you might have some nodes that have a role of being cloud nodes and others that are edge nodes. It will both synchronize metadata with the edge and give you kind of a cohesive cluster view. So I'm just digging into what all that can provide, but that seems pretty interesting.
Great. And just on, with all 3 of these, one of the things we were interested as well is, content. This is how we found you through the blog that you wrote. But when it comes to, leveling up or getting hands-on experience, getting your questions answered when it comes to these, these tools in particular, what are the resources that you use to learn? Are they blogs? Are they podcasts? Are they videos? We recently took a look at, data on Kubernetes is a recurring theme in our monthly content analysis. And a lot of times people struggle to find resources about that specifically. Of course, you can go to the official documentation. You can watch, talks from KubeCon. But what works best for you, Dave?
An all of the above strategy. Definitely lots of talks from KubeCon and other conferences. It is really hard to keep up, honestly. It's a very fast moving space. And I'll usually feel like I need to deep dive into something in order to really learn it. And even just a week or 2 with my head down at it, looking at one thing in particular, I'll look back up and the landscape has shifted a little bit. There's new projects gaining traction and new patterns that people are mocking that I used recently, things like that. And so trying to keep on top of things, like you say, besides, documentation for whatever you're working on and Stack Overflow, questions and answers, the CNCF Slack community. That's one place where I try to hang out, especially things like that Kepler project. That's where a lot of discussions occur. Reading articles, NewStack has some great articles, and even XDA developers. That one's a little bit more small scale, home lab, but it's a great inspiration for weekend projects. It has been for me.
Good. Now, we've talked about, the things that you're interested in, but for people who don't know you, can you just give us an intro, about who you are and what you do?
Absolutely. Hey everyone, I'm Dave Masselink. I'm a software engineer, and as of earlier this year, working full time on a startup project called Compute Gardener. Previously, I'd worked at Google's X Labs, Intuit, the financial software company, and Tesla Solar City years back.
Fantastic. And how do you get into cloud native? Well, how'd that journey start?
Yeah, it was a journey. That's the right word for it. Um, It started for me back probably 2016, 2017 timeframe when I was at Solar City or then Tesla after they acquired that company. I was in the energy side of the company, though, the grid systems team. And we were starting to deploy a lot of infrastructure that, supported our solar inverters and other things out in the field that for our customers. And we were starting to see infrastructure as code patterns. My colleagues were working with Mesosphere and Terraform and Kubernetes. That was where I first came across Kubernetes. And so then, as luck would have it, the summer of 2018, I was part of the largest layoff round to that point in Tesla's history. I think I was one of the 13% in June 2018. But as is so often the case with these things, that come to learn, it's a blessing in disguise, right? It allowed me to uh, have a really intensive kind of next job search and career focus, make sure that I was moving in the directions of my career that I wanted to, keep my technical skills sharp, even in a new data domain. And so, in particular, that was where I really got to dive into. I ended up at Intuit, the financial software company, and really dove into a cloud native there because I joined a team as a front end engineer, which is what I mostly had done in my career, but building internal developer platform tools. And so, ways to make it much easier for developers inside of Intuit to get up and running quickly with a project. I didn't even really know it at the time, but a lot of the folks on this team were, kind of, foundational in the cloud native world, I guess. The Argo team was sitting feet for me, Jesse and Alex. So I didn't even know how many great resources I had at that moment, but that was where I first got deeply into the cloud native world.
And what were you before getting into cloud native? What kind of stuff were you doing? What were you working on?
Yeah, I briefly mentioned a moment ago, but front end web stack is kind of where I've been mostly working throughout my career. Started off in embedded systems and fortunately kind of got pulled up the stack where I would help somebody instrument a solar field and get data into a database. And then they would say, how do we see it? How do we access it? Can we visualize it? And fortunately, had to learn on the fly how to do those things and found that the front end of the web stack, building React and Angular apps, HTML and CSS is an awesome place to be. Highly leverageable skill set. And, outside of the cloud native world, it's probably the most fast moving dynamic that I've been a part of.
And now, if you could go back in time and give yourself one piece of career advice, what would it be? And maybe we want to keep in mind you've got a startup now too.
Yeah, I think it's related to that. I mean, first off, if I could go back in time, I'd probably do something important with it. But if I could only do it to tell myself something, I would I would tell myself not to fear or be hesitant to have a circuitous career, a career that's not a straight line. When I first started off in my career, I think that I was afraid of anything else. I was afraid if you jump off the ladder, you ruin your career if you don't keep taking step after step all the way up. But I've definitely learned a lot since then. And, interesting people and interesting jobs isn't all there is to have in the world. But no doubt, a lot of the uh, more interesting projects I've seen have come from people who have had wildly varying perspectives because of a lot of lateral hops throughout their career. Even people who would take large stretches off and do teaching or a lot of family care or, reasons why they needed to focus on their family and then 10 years later jump back in. They always bring something new, a new perspective that, you don't even imagine you'll pick up. But anyways, I've tried to be less and less afraid of that.
So with that in mind, we're looking at an article that you wrote that we found titled "Billion a Carbon and Price Aware Kubernetes Scheduler." So we want to look at this a little more in detail. Data centers are becoming a significant part of our global energy consumption. Can you help us understand the scale of the environmental challenge that led you to build the Compute Gardener Scheduler?
Absolutely. Yeah. In terms of where we stand right now, the best estimates are probably about 4%. whether you're looking globally or the US, is actually about the same of electricity that goes to the cloud. The cloud is, classic data centers, a lot of, on-prem sort of data centers as well in the smaller scale, network infrastructure and all of that as well. All of the energy that goes into that, roughly 4%. I don't know if people really know this that well, but the US has had some really great achievements in energy efficiency in the last few decades. And so we had a shrinking pie in terms of the total US energy consumption, but we're at a different moment in time now with generative AI. All of those gains are starting to be lost as the energy demands are growing right now. So the projections, beyond that 4% that we're at now, that I was starting to see were that it should triple to 12% in the next 3 to 5 years. This is the US government had projected this. And again, that's not because the rest of the pie is shrinking. It's because everything's growing. And the thought that, all of these emissions are going to be added to the system if we do nothing, made me realize we have to do something. And there's nobody tasked with globally optimizing the electric grid. That means we all have to. And so we need tools to empower and enable us.
And
I guess beyond that, I'll say too that it kind of started from a side project. What inspired me to pursue Compute Gardener, I'd been in my J job, had come across the company Electricity Maps API. This is a company in Denmark that is able to aggregate and provide carbon intensity data. So we'll talk a little bit more about that later maybe, but my side project was I just installed a new power meter in my house and I wanted to see real time what was my power use as well. What were the carbon emissions related to that use? And got that set up and running, but was pretty quickly surprised to learn that, at least where I am in California, the intensity swings wildly. And I'll tell you a little bit more about that in a moment too, but that's really what kind of inspired me, got me motivated to thinking that there's some low-hanging fruit worth picking here.
the Compute Gardener scheduler integrates carbon awareness into Kubernetes scheduling decisions. How does this actually work at a high level for people that might not be familiar with it?
Using a strategy that is relevant outside the Kubernetes context as well. Broadly speaking, there's a couple different shifting strategies: time-based shifting, temporal shifting, and space-based shifting, spatial shifting. The time-based one is what we've really focused on so far. And so that's at a high level what the goal is to either shift a workload to a cleaner time to be executed or a cleaner place to be executed. So that's at a high level, and I'll be able to tell you a little bit more about exactly what that Compute Gardener does now as we continue talking.
Good. And you mentioned using real-time carbon intensity data from external APIs. What exactly is carbon intensity, and how do you measure it for different power grids?
It's a metric that is attempting to show kind of like the cleanliness mixture, the green mixture of the grid, like for all of the resources that are contributing at a moment in time to the grid. Roughly speaking, is it very clean, very dirty? And so the unit that carbon intensity uses is grams of carbon dioxide per kilowatt hour, roughly. And so that means for a unit of energy, we're talking about how many grams of carbon dioxide get emitted. Like I said, I was very surprised as I really dug into this and saw some of the data in my region. I'm in Northern California, Cal ISO region. And here, middle of a sunny day like we are now, it's probably about 50 grams of carbon per kilowatt hour. In the middle of the night, I was starting to see we were up to 250, 300, 350 grams of carbon. And so this is not a signal that the utility passes through to you for you to act on, but it is reality nonetheless. And it motivated me to say, you know what, I can build some tools that make it easier for folks to use this signal.
Now, beyond carbon awareness, you've also built in electricity price optimization. How does this time of use pricing work, and why is it important for Kubernetes workloads?
Off the bat, I'd say it's not important for all workloads. And I'll tell you, really quickly about what time of use is. This is a pattern or a program that's implemented at a lot of utilities where they allow you to opt into a different rate structure, let's say electricity is normally 15 cents per kilowatt hour on their normal rate, but you opt into the time of use rates. Then during peak windows, there's peak and off peak times. During peak windows, you actually pay more for electricity, but you sign up for this because during off peak windows, you pay less. So just to put some rough incorrect numbers to it, maybe during the peak window, you're paying 20 cents per kilowatt hour. And then during the off peak, you're paying 10. So either way, swinging 5 cents from what you would have paid if you're not on that rate plan. This is a rate setup that is most common in kind of the smaller commercial and residential contexts. So it isn't relevant in all data center contexts. Often, as best I understand, data centers will attempt to procure large amounts of energy upfront through power purchase agreements. And so they still are contributing to, all of that power is contributing to emissions, but the costing, the way it's costed is different. So that's roughly how time of use works. The way that we in Compute Gardener work with it is, as it is a fixed schedule, the utilities want you to learn this new schedule and be able to change your behavior accordingly. As it's this fixed schedule, it's pretty easy to say, if a job comes through and one of these peak windows, let's just delay it until an off-peak window and let's track how much energy it used when it ran. Therefore, we can estimate how much money we saved. But again, it's especially relevant for kind of the on-prem, smaller scale residential home lab sort of contexts, but potentially more and more so in cloud contexts too. There are some cloud providers that are really focusing on advertising what the carbon intensity makeup of their energy is.
And let's talk a little bit more about the technical implementation. You built this as a Kubernetes schedule plugin using the scheduler framework. What were the key design decisions that you made?
Probably more mistakes than decisions, but yeah, when I first started, after I kind of realized roughly what I thought the project should be, there were other people who had explored similar things in the past. It shouldn't be too surprising. Lots of white papers and academic papers, and one from a few years ago that was pretty close to what I thought should be done. And it was using the scheduler extension concept. And so I started there, but pretty quickly learned that's an older pattern and doesn't work as well as the scheduler plugin framework. So the plugin framework is really interesting, as it sounds like it's plugins. You think that's just kind of like add-ons and ancillary things, but in this case, it isn't actually. Everything that you appreciate about the Kubernetes scheduler, its ability to do resource constraint scheduling, its network constraint scheduling, all of those are individual implementations that are imported as plugins, and so it makes it really easy to build your own scheduler, pull in all of that you want, and then implement just the differentiating parts that you care about. So yeah, in particular, the scheduler framework has a dozen or so different places along that filtering pipeline that you can implement. There's two that we have to implement. One is the pre-filter stage. This is where you're considering a pod in isolation. You're with some global conditions. And so this is where you first hear about the pod. It's just been created. You're curious if you can schedule it, and you can check certain things like, are we in this time of use peak window? If so, wait. Are we in a carbon intensity, a window where it's too high in carbon intensity? If so, wait. Yeah, so at a high level, that's what the scheduler is able to do with those, at the pre-filter stage. The filter stage is a little different. This stage, you are now considering nodes too. You're considering which node to bind the pod to. So you end up getting that function called with a node pod pair. And so if we have data about the nodes in terms of their hardware, what hardware they're running, and we have data about the efficiency of that hardware, we can attempt at that stage to place the job into more efficient hardware or not. So that's what happens at the filter stage. And those are the two most important stages that we needed to implement.
Now, I think that one of the biggest challenges must be accurately estimating energy consumption for different workloads. How do you model power usage across CPUs, memory, and GPUs?
It is one of the most difficult parts. But before talking about that even, I'm going to take a quick break and say that it is not necessary to track energy in order to have real world positive impacts in carbon emissions. You can pick up our open source scheduler and have no tracking whatsoever. And as long as the jobs are being shifted to cleaner times, it will be having a net benefit on everyone. It just is the case that you cannot prove that to anybody for purposes of pats on the back or anything else. So in order to be able to track and prove this, which we also want to be able to do, yes, then it requires us doing some energy tracking. And so, yeah, it's different in different components of the compute. For GPUs, these are such energy intensive devices that I think energy was kind of considered from the ground up for these. And so, like for instance, NVIDIA has a piece of software called DCGM. I think it's their data center GPU monitor or something. It gives a pretty good estimate of full card power, not just the core, but full card. And then you can apply a power usage effectiveness ratio on top of that and have a pretty good estimate of what the GPU is pulling. It's different though in CPU and memory. I mean, the history of computing is such that it just wasn't really there weren't real-time power features built in from the beginning of everything. So for those, we have to do something a little different. We have essentially an estimate, a model, a way to determine based on what we do have visibility over, the CPU utilization, memory use, things like that. How do we map that into the energy that is used? And so that's some math and some estimation. I will say as well, since this blog post was posted, we have started integrating Kepler as a data source for power as well. And so thus far, it's looking like it'll be a nice, accurate approach, although there's a fair bit of overhead, so we're not sure if everybody will want that. So we'll probably be supporting both moving forward a nice standardized community importer like Kepler, as well as our model, which is based upon the Green Software Foundation's software carbon intensity methodology, but then it picks things up and goes a little bit from there, where we take into account dynamic frequencies of the CPU, and we, rather than just a linear model of saying, okay, at 100% utilization, here's our power, at idle, here's the power, and there's a straight line between. That's honestly a pretty good estimate, but you can get a little bit closer if you use something called the power law method for estimating. And it sounds more complex than it is. It's just saying it's not a line, it's a power relationship, an exponential relationship. And so that's what our model is able to do. And like I said, we're building out to support more advanced exporters as well.
Given that performance is critical for any scheduler, how did you ensure the carbon and price checks don't add significant latency to scheduling decisions?
Yeah, definitely. The latency and performance for a scheduler is definitely a critical consideration. We definitely put some thought into it. Along the lines of what you'd expect, we trying to take everything out of the scheduler's critical path. So essentially what you don't want is to say, hey, we just heard about such and such pod. Do we want to schedule it? Well, let's go check now at this moment. What does the API say? Of course, that could take too long. It could fail this particular request. And then you're left wondering what to do. So instead, we've got a couple background processes that are periodically going to check the data that we would want, caching it. So there's always accessible for that much shorter critical path of the scheduler at the decision point. That's essentially what we've been trying to do. We've been able to get it down to the P95 latency down to less than 100 milliseconds. We think that's a place that we can keep working from. And
for developers who are out there who are interested in using Compute Gardener, how do they configure their pods to be carbon aware? What control do they have over the scheduling behavior?
Yeah, lots of control ultimately, but another of the goals was to make it quite simple to get started. And so once the scheduler is deployed with a Helm deploy inside the cluster, there's only one line that needs to be changed in a pod or a job spec, and that's the scheduler name. If you see scheduler name in pod specs at all right now, you almost always probably are seeing default as the scheduler. That's the default Kubernetes scheduler. But if you specify a different scheduler, a secondary scheduler, the Kubernetes will honor that and send it instead to the deployment representing that scheduler. And so maybe want to belabor that point really quickly too, which is to say that this is very much opt-in. It means that no compute jobs whatsoever that aren't really focused on or that don't care about the scheduler will ever even know that it exists. It's only the jobs that are specified to opt-in that it'll ever touch. In terms of of the control that the developers have, yeah. So once you add that line of scheduler name, that's all you need. But oftentimes you might want to override some of the defaults. The defaults of carbon intensity, I think, is 150 grams, and the default max delay is something like 24 hours. But you've got a job that's semi-critical, right? It doesn't have to be run right now, but you want it to be run relatively soon, so you can go with a higher carbon intensity for that, maybe. And 24 hours isn't going to work for you, but 12 could. And so you can override both of those things with custom annotations on the pod or the job. But there's more than that, but in terms of different dimensions of flexibility, but I think that's probably the simplest example.
Great. One thing that folks I think is important to keep in mind is that this is not necessarily just an initiative about wanting, greener energy for the sake of greener energy, but actually looking at results. You mentioned some in your post, you mentioned some very impressive projected results, 50% carbon reduction for deferrable workloads. Can you break down exactly where these savings come from?
Absolutely. At the top, though, as with anything like this, your mileage may vary is a very important thing to say. And the reason why that's so important to say is because, like I've already kind of alluded to, a lot of this, carbon emission arbitrage opportunity that exists is because there are wild swings on my local grid. And that's not exactly the case everywhere. It's becoming more and more as we've got good renewable penetration throughout the day. But I just really want to point that out, that it just doesn't mean that everybody in the world can install this and immediately see 50% carbon emission savings. Another thing I'll really quickly say is to really drive the distinction. There's no energy savings here, or at least in the example we're talking about here with the 50% carbon emission savings. The exact same amount of energy occurred either way. The same jobs were run. They took the same amount of time to run. The difference is when we ran it and what the carbon intensity was then. And so in California ISO, it's, as I mentioned, there are these wild swings, like 5 times, 7 times over the course of the day. You could, 7x what you could be emitting versus another time. And so our test setup was a regular cron job, hourly, or maybe even more frequent, that we would run a set of benchmark jobs. And then in high intensity periods, the scheduler would step in and delay them, wait until we got below the carbon intensity threshold and run them then. And again, because of our grids, my grids, wild swings, it made it pretty easy for us to be, I think we're up in the high 50s ultimately, but I thought 50% is pretty impressive enough as it is. But it was due to our setup. I don't think it's a completely unique setup or pattern for jobs, but it isn't everybody's either. So it's worth pointing that out.
Energy visibility seems to be a key benefit beyond just optimization. What insights have users discovered about their workloads that surprise them?
I don't know. They oftentimes don't have a baseline for surprise, if that makes sense. This is something that nobody's been tracking in cloud compute. When I can go back to a team and say, this service is taking this number of kilowatt hours per month, and here's what the emissions look like. This namespace is doing whatever. They kind of just initially will look at me and say, oh, okay, let's try to bring that down. It's less a surprise about where they start. And then, okay, now we've got a number to track and to try to optimize. Probably the thing that surprises me the most, although it really shouldn't, since we are humans and we are social competitive animals. This is something I've experienced a few times where I'll go to the person that I'm coordinating with and the partner company and share with them what their service is, what their team, what their emissions and energy use look like. They very quickly often want to say, what about that team over there? How do we compare to them? So that's an experience that I've had a few times where there's good-natured, competitive, cross-team, behavior that benefits us all, I suppose.
All right. Looking at the broader ecosystem in terms of cloud native technologies, How does your approach compare to other carbon-aware computing initiatives like KEDA or Kubernetes Event-Driven Autoscaling, CNCF project, like KEDA's carbon-aware scaler or cloud provider sustainability features?
Really quickly, I'll talk about cloud providers first because I think it's a little distinct. So cloud providers, maybe like AWS as an example. I forget what it's called, but they've a few years back put in to their billing system uh, a method or a mechanism where you can look at what the likely emissions impact of your usage was. Um, this is always post fact. It's always last billing period. So it's not the sort of thing that you can operationalize and use today for decisions today exactly. Um, but I'm really glad that they have it. I'm glad for any insight that the cloud providers give to their customers in this way. The other thing I guess I'll say too is just when it comes to cloud provider solutions, that's a single cloud provider. It works for some people. Some people are AWS ride or die. Some people want to be cloud agnostic too and want tools that are cloud agnostic. And that's part of our goal as well. Is whether you have some of your compute in AWS, some in GCP, some on-prem, you're going to want one place to look at all of that. And so that's what I was going to say really quickly about providers. In terms of the other tools in the space, at a high level, I think we're all rowing in the same direction, and we've got really complementary tools. So KEDA, like you said, is about auto scaling. It uses, I believe, the carbon intensity signal that we've been talking about for triggering auto scaling decisions and downscaling decisions. There's another project that's a little similar called Cube Green that I came across a little bit here recently. They are doing something a little different. They have some mechanism for snapshotting running pods and sleeping them. And so their use case is, you've got a workforce that is only interacting with this infrastructure Monday through Friday, working hours, and why should you be paying for it at other times? And so they make it very simple to define what that schedule is and have all of everything that you opt in go to sleep during certain stretches. So this is not just deferrable workloads. This is, all of your workloads. So just different approaches, different strategies. But the most important thing I think to point out is they can all work together, and the commission savings stack. So you don't have to pick one tool and go with one approach. Pick many.
So you're actively seeking production validation partners. What kind of organizations or workloads would benefit most from deploying the scheduler?
Yeah, I think a lot of folks would benefit. The sorts of teams that we're looking for most specifically right now, kind of on the small to medium scale, just that'd be what we are best able to support. As well, folks that are forward thinking and want to try something like this out. Probably as well, folks that have a bit of a hybrid cloud setup where they have something in a public cloud provider, some on-premise infrastructure as well. The reason why that would be beneficial is just that the on-premise infrastructure is something that's usually a little easier to validate the energy use of. And so that's going to be a relevant portion across the partnership, I'm sure, is making sure that we're accurately estimating that. And so having some on-prem hardware would be a good approach to start with.
The roadmap also mentions exciting developments like carbon credit integration and cross-cluster scheduling. Could you paint a picture of where carbon-aware computing is headed?
Let's see. Let me take the cross-cluster scheduling first, because we kind of touched on it before. So, like I said, we've really focused on temporal scheduling so far, but we're starting to shift because there's a different stack of carbon savings potentially if you can move from one cluster or cluster region to another that's much cleaner. However, the reason why we didn't focus on that initially is that it also brings up many more nuanced, thorny questions. Most compute doesn't operate in a vacuum. It operates on data, and you need that data there for the compute to occur. And so when you're inside of a cluster and just saying, let's wait till later, you just let the data sit there. But if you have to move the job to some other cluster and you don't already have the data there, then you can have some time delays related to that, perhaps egress fees in the worst case, and other things that start to make you question whether it's even worth making the shift in the first place. But those are the thorny questions and corner cases that we're starting to work through right now. So you're catching me in the thick of it. beyond that, the carbon credits. So that's probably something that's one of the potential programs in our future that I'm most excited about. So I'm an energy nerd and have been tracking carbon credits and marketplaces for a while. Just for folks that maybe aren't as aware, kind of the most classic example of a carbon credit is where somebody will go and plant many, many acres of trees and say that these are going to be a carbon sink for the next 30 years. And so then they are given some set of carbon credits by the marketplace authorities, and they can go and buy and they can go sell those for money. So that's roughly what a carbon credit is. And the reason why it comes into play for Compute Gardener is that once we have enough visibility over what our customers are doing in terms of taking actions to mitigate carbon emissions, because we know what job came in, what the intensity level was then, when it ran, what the intensity level was then, how much energy it ended up consuming. So we've got great telemetry along the way for tracking this. And at that point, we've got everything I believe we will need in order to validate the actions for purposes of carbon credits. So I'm a software engineer and I will not be able to build that program alone. We'll definitely need to be bringing in some policy and legal experts in the near future as we get to that point. But I'm very much excited for it. I think it will really shift thinking a little bit. Like right now, software engineers, DevOps engineers, platform engineers, whatever we're going by these days, we're expensive, right? And our teams are cost centers in the org speak. And I've been in enough of those higher level org speak conversations to know that if there's a team that is bringing in some money, even a little bit, it just changes people's thinking. Now it's not just a cost center, it's also a revenue center, and it's not an offsetting revenue stream, but it's one that could potentially be pursued further in the future, and it could grow. And it gets people thinking about the green that they actually care about. And for your listeners not watching the video, I'm rubbing my fingers together as if there's a dollar bill in it. Okay. Now,
never done that before in a podcast. So that's a good start.
At the last minute, I was like, I have to explain what I'm doing. Not everybody's watching. So yeah, I guess that's what I say. It's just we often have to tie carbon savings back to dollars and cents savings if we can. It's not always possible because Compute Gardener is, again, really focused on limiting the carbon emissions as opposed to limiting the amount of energy used. Often the same amount of energy is used. But where we can get this new dimension of potential revenue, that's what we're trying to provide for our customers.
And for teams that are out there that are interested in contributing or adopting the Compute Gardener, what's the best way to get started? And what should they know before diving in?
Start small if you want to. And making any change to infrastructure can be scary, risky. Start with your least important job running on your least important dev cluster, and try it out and let Compute Gardener run for a little bit of time. Make sure that you understand what it's doing and why it's holding the jobs back at certain times and why it's not at others. But really, I guess I would say, jump in. We have got a simple Helm chart for the install process. The only requirement really is that electricity maps API key, but it's the free tier for a single grid region, so you won't need to pay any money for that. And beyond having conversations and GitHub and such, I'm always up to talk with folks in person over the internet about this topic and hear what tools they're using that are similar, that are different, because we're all trying to figure out what that optimal stacking is as we are trying to empower ourselves now to make these changes.
I've got one bonus question because currently we're both in California, but normally I'm based in Europe. In terms of what you're working on with Compute Gardener, what considerations are being made for the European market when it comes to sustainability, efficiency, green energy, things of that nature to make Compute Gardener more scalable? Have you interacted with users in Europe and heard their concerns to contrast with things that are more focused on the US market?
We have not coordinated with too many customers in Europe. That being said, especially in the green software, clean software communities, Europe is kicking our ass right now, the US's ass in terms of the amount of participation, the amount of real steps forward that are being provided. So even though it's the case that I'm less familiar with the energy markets and cloud markets in Europe, honestly, those are often the more forward-thinking teams and places where there is not currently political question marks around whether or not something should be done. And so at least I would appreciate that aspect of getting to work with potential European partners.
Fantastic. Yeah, I met folks from Leaf Cloud a few years ago. So I've been hearing about what they've been doing. Also working with some folks in the UK that are interested in this topic. So it's something worth exploring further. Dave, what's next for you?
Yeah, well, focusing on Compute Gardener still, trying to gain traction with the project, trying to find those forward-thinking teams that I can partner with, and we can implement some of these patterns, really start to prove the value of it. Beyond that, personally, I'm planning to attend KubeCon this year in Atlanta. It will somewhat surprisingly be my first time ever, so I'm really excited about that. Hopefully, I'll get to meet you in person, Bart, and lots of the listeners.
Likewise. And for people that want to get in touch with you, Dave, what's the best way to do that?
Certainly LinkedIn works, our GitHub project page, you'll probably link both of those, or our website, compute-gardener.com. Any of those should work.
Absolutely. Dave, thanks so much for joining us today. Look forward to speaking to you soon and see you on the ground in Atlanta. Take care.
Ditto. See you, Bart. Thanks so much.
Cheers. Pleasure.